Alright, so I'm going to go over number 21 and 8.1. Determine if the given matrix Q is an orthogonal matrix, and see method 8.1.4. So to start off, in the book definition 8.3 states that an orthogonal matrix is an n-by matrix whose columns are an orthonormal basis for Rn, which means that that each column is going to be a unit vector in the matrix. And so I grabbed this straight from the book method 8.1.4. To determine if an n-by matrix Q is an orthogonal matrix, multiply the transpose of Q by Q, and then the result is going to be the identity. If the result is the identity matrix, then Q is an orthogonal matrix. Otherwise, it's not. So the first thing I did was grab the find the transpose of Q, which are right here. And then I think the easiest method would be just to plug the inverse. I mean, not the inverse. The transpose times Q. Just to plug it in the calculator, since we're essentially just trying to see that if it's the identity matrix. And then so plugging in the calculator will give me this matrix right here. With vectors 1 0 and 0 and decimal. And since multiplying the transpose of Q by Q is not the identity matrix, since there's not a 1 in each column, then therefore Q is not an orthogonal matrix. And then the reason why we multiply by the transpose of Q is because the book states that if Q is an orthonormal basis, then the inverse is going to be equivalent to the transpose. Yeah, that's how you solve